Welcome to Chemistry with Mrs. Levin. We are ready to start off all of our chemical knowledge with a brief introduction of chemistry, which is closely followed with Chapter 2, which is all about matter and change. Okay, so first thing we have to do, since this is going to design the layout of our entire course, we need to actually define what chemistry is. All right, chemistry is the study of the composition and the structure and the properties of matter and the changes that they undergo. Sometimes there's energy changes with these processes, but the big important thing to remember is that we are looking at the composition and the properties of matter and the change that they undergo. Okay, so when you take a look at leaves, whether you are in the springtime and then they change in the fall, that is chemistry. Glow sticks, okay, having that luminol get activated by the hydrogen peroxide inside, everybody's favorite fireworks. Baby, you're a firework. Okay, unfortunately, we have weapons of mass destruction like nuclear bombs, and this is called a mushroom cloud, or even something like your Gatorade Zero. Okay, all of this has to do with chemistry, everything in your everyday life. Okay, so if you're asking things like, what's in my substances? What am I eating? What am I smearing on my body when it comes to different beauty products or acne treatments? Okay, whether you were talking about things that are heated or cooled and mixed with others, and how all of this behavior occurs, that is chemistry. So, pretty much, it's a study of everything that you see in our universe. Now, when I was getting my master's at Arcadia, one of the things that I put for my thesis is that everybody can learn about chemistry because it's all around us. You just need to know how to see it. So, in our entire wonderful blue planet, there is so much to see. And that's one of the reasons why I fell in love with chemistry, is because once you see it, you really can't unsee it. You start to see that there is chemistry in the air, in the water, everywhere. So that's going to be my awesome task this year, is to get you to see chemistry. Now, if you want to think of chemistry as having branches, get it? Tree having branches. We can make sure that we have a good understanding of like the basic areas of what we're going to cover. All right, now everything in the universe is really overwhelming, so we're going to break these down into 5 major branches. Okay, organic chemistry, inorganic, analytical, physical, and biochemistry. Yeah, bio, like last year. All right, and their names even suggest what you already think that they are about. Okay, so let's take a look at each one of these. First, organic chemistry, my personal favorite. Organic chemistry is the study of all substances that contain carbon, and that is the big um, qualifier for organic chemistry, because carbon-based substances are what we have all living things on our planet. Okay, our petroleum-based products, which are going to be our plastics. Okay, our fuel sources. Okay, that's going to be your gasoline. That's going to be your alcohol. That's going to be your jet fuel and rocket fuel. All that stuff is going to be studied in organic chemistry. Okay, carbon can make 4 bonds, which you might have gone over in biology class. Okay, so it can bond to 4 things and make this really intricate backbone and the basis of our living things. So when we look at chemistry, we are, our organic chemistry, we're really looking at how things are going to interact with our carbon atoms. Okay, your petroleum-based products, your plastics, are really the decayed matter like decayed leaves and stuff over hundreds of thousands of years ago. That's why they are non-renewable resources because they don't um, replace themselves in one human generation in 80 years. Okay, so if organic chemistry is the study of things that contain carbon, what is inorganic chemistry? Inorganic chemistry do not contain carbon. So these are non-living things like rocks and precious metals, jewels, mining for copper, for silver, for gold, for tungsten. Okay, the diamond here is carbon-based, but the metal that holds it, if this is white gold, okay, is going to be inorganic. And inorganic chemistry is really going to have this analysis of rocks to see what makes up your rocks, whether it's going to have silicon in it or not, iron, copper, depending on what you are looking for. Okay, analytical chemistry is pretty much what it sounds like as well. To analyze something means to study it, to figure out what's inside. So we're looking at what the study of the composition of the substances are. So this is like all of your CSI crime scene shows where they're finding like teeny tiny minute traces of different kinds of medications or narcotics, anything like that. Forensics, when you want to know how much of something there is in a particular substance, it really is going to be an awesome avenue where you're looking at these very teeny tiny amounts and looking at what's inside. Okay, physical chemistry is where we're going to study the theories of the experiments and the behavior. So really, it's going to be how things are going to move and interact. So how things will uh, bend and stretch like nylon, the Teflon of your frying pan. Okay, that's space technology. All right, so they put it on the bottom of like a space shuttle so that it doesn't burn up upon reentry when it comes back into the atmosphere. Well, they were like, oh, look at that, it's really slippery. Let's put it on a pan and let's have some space eggs. Isn't that cool? Um, Bathing suits. This is the great Michael Phelps. And when he was, I used to coach swimming for a long, long time. And when he and Speedo introduced their like shark fin suit or shark skin suits, it ended up changing the entire dynamics and they couldn't wear these full body suits and stuff anymore. Chewing gum, how gum keeps its flavor. Like that's what a physical chemist does. It's really, really interesting how all this stuff kind of um, it creeps up into our everyday world. All right, and lastly, our branch is going to be biochemistry. That is the study of how chemistry is in living things. Okay, so if biology is the study of living things and chemistry is matter and change, so it's how matter and change are going to be in living things. Awesome. So, how do you digest your cheeseburger? You get a cut. How does your blood clot? If you breathe in air and exhale, how does that work? How does that all get integrated in your lungs? Why are you unable to think when you're hungry? All of these different things, how your medicines work, all of these different things are biochemistry. And the really cool part is that you can't learn one of these branches without the other. So you will see that you'll have lots and lots of overlap, lots and lots of interactions between all the different parts. All right, the next section of our book talks about chemistry far and wide and talks about how the materials have changed over the course of history. Okay, is used to make our lives easier and better. Like a long, long time ago, like 3,000 years ago, they made, stuff out of iron. But then it rusted and it broke apart. So that was really crappy. But if you mix some iron and some carbon, which they got from fires, which they got from ash, you know what? it made steel. And that's where we started to see things not rust. We even have like stainless steel, where, things aren't actually going to be affected by water or air or being outside. They have buildings and bridges, all of that. Okay. Gold is really expensive but soft. But if you mix some copper and some zinc together, you get brass. Bronze statues don't change color. If they were just copper, that's when you see your Statue of Liberty. Um, and our Statue of Liberty, we know, has kind of changed different colors. How we use ceramic plates um, instead of eating out of leaves and coconuts and stuff like that. And today, obviously, our world is governed by plastics, which is why it's so important to recycle them because they are not renewable. You have plastics in every single facet of your life. You can't even count how many times you have plastics on your everyday life, from bottles and bags and, well, we don't really use CDs anymore, but your inhalers and your pill bottles and tape and everywhere, absolutely everywhere. Okay, so when we talk about chemistry, we're also talking about the energy and how it's transferred. Everybody knows our lovely little Teslas here, our electric power cars, and they have their charging stations here, and where we end up fueling them from. Hopefully, one day we can have solar shingles on our houses, and they can charge our cars and power everything. If you go towards the Jersey Shore, you see the great big huge wind turbines there. Is nuclear power safe? All of this is covered in chemistry. It's pretty amazing to get through. And lastly, chemistry is obviously going to be in medicine and biology and biotechnology. Okay, chemistry is more than just stuff in the lab, but it is important because you do see it in the lab. All right, so if you've had any of those genetic testings, those 23andMe, Ancestry.com, okay, they've all used chemistry in order to assess what is on the inside because all of these bonds in your DNA are going to be different chemical elements and they look for different sequences of the genomes and the elements that are in there. Your vitamins and your medicines and how you get cavities. What do we use to prevent cavities in our toothpaste? That would be fluoride. All right. How chemistry is used in agriculture, making hardier and more productive plants, the stuff that they're spraying on them. What are the effects of that? Our environment, okay, clean air, okay. This is post-COVID and this is pre-COVID and how much the air cleaned up because we weren't using cars to get back and forth to work. In the 2008 Beijing Olympics, okay, another thing with Michael Phelps over there, athletes were complaining about how much smog was in the air. So they put a ban on all combustion engines, all cars and stuff in the city, and for 2 months, and then it cleaned up the air because we have lots and lots of waste gases in the air in places like China because they don't have these restrictions like we do here in the United States, like the Clean Air Act. Um, Air Act of 1974, where we put all these regulations in. That's why a lot of products are made in China because they don't have the regulations and they can be cheaper. So that's a crazy ethical issue there with buying stuff made in China. And then obviously, we're always looking for life on other planets. So we have astronomy, space exploration. We've seen the movie Martian. Will the sun die? Is there life on other planets? Who knows? Is there water on other planets? Looks like we need some H2O. So we're always looking for that. So this is your introduction to chemistry, and I can't wait to show you more.